So all of these probabilities are for people who are 16 and older and do not work for home. So that's going to be the base of our tree diagram. Now in the stem, it says the survey also concluded that 46.9% of this group we just described are female. So if we subtract that 0.469 from 1, we get 0.531 as the proportion of males who are 16 and older and do not work from home. Now, other than sex, our other variable of interest is leaving time. So we have people who leave before 7 a.m. and people who leave at or after 7 a.m. So in the stem, it says 38.3% of the males leave for work before 7 a.m. If we subtract that from 1, we get 0.617 as the proportion who leave at or after 7 a.m. For females, we're actually told the proportion that leave at or after 7 a.m. is 0.747. So if we subtract that from 1, we can get the proportion who leave before 7 a.m., which turns out to be 0.253. So far our tree diagram has branches for female and male, and then each of those branches break off into people who leave before 7 a.m. and at or after 7 a.m. Now the last thing we're going to do is calculate the AND probabilities that go out here. So this will tell us what's the probability that a male leaves before 7 a.m. We can get that by just multiplying 0.531 and 0.383. And let's find the probabilities for the other three groups. So now that we have our tree diagram, finding these probabilities is going to be pretty easy. So the probability of being male and leaving before 7 a.m., we just follow these branches, and it's this probability right here. The next one says, what's the probability the selected person leaves before 7 a.m.? So we need to consider both females and males who leave before 7 a.m. So that's these two groups. We can just use the general addition rule to add these two probabilities, since the events are mutually exclusive. The probability of before 7 given female equals the probability of before 7 and female divided by the probability of before 7. Now, if we look at all the probability associated with leaving before 7 a.m., it's this probability and this probability. Of all that probability, the probability that's associated with females is this probability right up here. So we're basically going to divide this by the sum of these two. So that turns out to be 0.118657 divided by 0.32203, which is approximately equal to 0.3685. All the formulas used on this problem are on the AP Stats formula sheet. You just have to know the right time to use each formula. Let's take one last look at the tree diagram. I replaced each of the probability values with what they represent. So right here is the probability of being female and the probability of being male. And right up here, this is the probability of leaving before 7, given that you're female, since we've already traveled down the female branch. And then way out here, this is the probability of being male and leaving before 7, since we've traveled down the male and before 7 branch. I've also added some colored dots, and each of these sets of dots represent probabilities of 1 as a sum. So since everyone in this survey is either a female or male, these two probabilities have to add to 1. Also, once it's determined that you're a female, you either leave before 7 or you don't. So these two probabilities add to 1. Also, these add to 1. And then out here, all 4 of these probabilities add up to 1. Because you have to fall into one of these 4 categories. Like this video? Check out my book, The Ultimate AP Statistics Practice Book. It's got 100 problems, all with videos just like this. You can pick it up on Amazon.com.